This is Precalculus Chapter 13, Lesson 2, continuing on statistics. So now we are going to measure where the center of the data is and how the data is spread out. The center of the data and how the data is spread out. Okay, so I'm going to go ahead and give you these measurements, then we're going to talk about them, okay? So we measure the center with either using the mean, you know what the mean is, right? It's the average. We use the median, and we can use the mode. Mean, median, and mode are measures of where that center of the data is. Spread, which is like the variance of the data, how it's spread from the center, is measured by using the range. Y'all know the range. By using the standard. Okay, I can't even write. Standard, that doesn't even look like standard. Standard, maybe I should write the whole word out. Standard deviation. Or we can use, do you remember the box and whisker plot? That's what we called it. Box and whisker.
Kind of. I don't know how to do it, but I know.
Yeah, well, we're going to learn how to. Remember, it looked like a box, and then we had whiskers. Well, it's really called the interquartile.
Can we just say box and whisker?
I know. Well, I was trying to tie it to what you did. Interquartile range. Okay. And there are 5 key values that you need to be able to graph this. But actually, you know, your calculator will do this. Okay, so we're going to start with center, okay? The center, the mean is the average, right? It's just the average. What do? You add up all of the outcomes and divide it by how many outcomes there are, right? It's just the average. The mean is not always a good measure of center. All right, so look at example 1. The mean number of accidents. Okay, look, it says a 6-month study, so everybody get their calculators. A 6-month study of a busy intersection reports the number of accidents per month are this. Okay, so we're going to let our calculators do this for us. Okay? All right, so you ready? Okay, just turn it on. That's it. So far, turn it on. All right. Hit the stat button, S-T-A-T, right below delete. Everybody see that?
No. Oh, yes.
And edit. So you should have list 1, list 2, list 3. Do you see that?
Oh.
Everybody see that? Do you have numbers in list 1?
Yes.
Okay, so on your calculator, go up, up, and list 1 should be highlighted. Hit clear and go down. It should have cleared the list. You got it? Okay. In list 1, we're going to put these values. 3, enter. 8, enter. And so forth. 5, enter. 6, you will enter it as many times as it appears on the list. So we put our numbers in list 1. Got it? Do second quit.
What if there are numbers in list 2?
We're only going to look at list 1 because I'll show you in a minute. We're going to tell the calculator what list to look at when it calculates the statistical data. Okay? Now go back to stat. At the top, go over to calc. And number 1 is one variable stats. Do you see that? Hit enter. Look, it says, what are we going to do statistics on? Does yours say list 1? That's why we put in list 1, because that's the default. Hit enter, enter, and enter for calculate. Got it? X with the line over it is the mean. So what is the mean? 6.33.
You just do it normally.
You can do it normally. However, this also gives us the standard deviation. That's why I put in our calculators, because this. All right, so actually, let's go down. Do you see this on your calculator?
Oh, yes. Yeah.
That's the standard deviation. All right, and if you go down, there's 6 more numbers. Or 5. It gives you your 5 key values. Your min is 3. Quartile 1, 5. The median is 6. Quartile 3, 8. The max is 10. So I could draw my box and whiskers plot if I needed to. It also helps me find the range. Okay, I'm really jumping ahead. The range is the max minus the min. Okay, so I've really jumped ahead. All right. But it's good to be able to see all of this in your calculators. All right, now, when is the mean not a good measure of the center? Well, the mean is not a good measure of where the center of your data is when you have this big outlier. Okay, so notice these numbers hovered around, they just went from 8, 5 to 10, right? They just went from 5 to 10. And the average was what, 6.3? All right, let's go change one of those numbers. Let's go change the 10 in that list. Are you with me? Go change the 10 to, no, a big number, an outlier, one that's so far away. So 150.
40 billion.
40 billion?
That's a way big outlier. I would even say 100. Let's just do 100. 100. Everybody got it? We changed 10 to 100. You probably could have even changed it to 50, because that too would be an outlier. Now go in and do stat, calc, and your statistics.
21.3.
Is 21.3 really a representative of the average, the center of those numbers? No, because the majority of the numbers are to the right of that, right? That outlier moves the mean. Okay, so originally the data was symmetric. So that means the mean is a good measure, right, of the center. But when we changed it to 100, how did that change the shape of our data? It skewed it. Which way? Right? We have this one big number out here, huh? And all the numbers are way in here. When your data is not symmetrical, like there's these outliers either on the left or the right, the mean is not a good measure of center. So when you have the outliers, you're going to look at the median, the middle number. All right? So When do we want to use the mean? When our data is pretty symmetrical. When do we want to use the median? When we have these outliers. We're skewed left, we're skewed right.
So like an example 2.
So in example 2, that is correct. You see you have houses between 98,315. Then you have this house 2.5 million. That's an outlier.
That's a house I'm gonna buy.
Right? So that if they were calculating the average price of a home in that subdivision, look, it's 584,000. That is not a good measure, right? Of the center, the average. So in that case, you're going to use the median. What is the median? It's literally the middle number. You count to the middle. If there is an odd number of values, it's the middle. If there's an even number, it's the average of the two middle. So, I'm just going to make up numbers. 3, 4, 5, 5, 6, 2, 4, 6.
For example 2,
Okay.
the mean is
Here we go. We have this many numbers. 1, 2, 3, 4, 5, 6, 7, 8. An even number, okay? To find the median, I always just let my fingers do the walking, right? This would be an example of when we would use the median because of this outlier, okay? So we count, here's my two middle numbers. I take the average. So the median would be 5.5. It was obvious to me what was right smack in the middle of 5 and 6, right? You add them, divide by 2. If there's an odd number of values, you just take the middle value. Does that make sense? And example 3, they actually take the median of those home prices. Okay, so these two, the mean and the median, are typically used for quantitative values. So numbers. These are with numbers, right? The mode, even though we do use the mode on most of your math tests, most of the time we use the mode with numbers. It really is used most with qualitative data. And it's the one with the highest frequency, right? It's the one that's reported the most. You are used to seeing it with numbers in your math textbooks. But those numbers have typically represented some qualitative information, all right? Well, let's just look at the example in the book. Well, I need to say something. Okay, so there can be no mode. So 3, 4, 5, 6, 7. There's no mode. Every number has the same number of values. It could have been 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Every number appears the same exact number of times. There's no mode. So you can have no mode. You can have one mode. You can have two modes. Okay? So you can have no mode. Some data can have no mode. You can have one. You can have two. Typically, there's only one, right? Like on the ACT, if they ask you the mode, it's the most, right? Median is the middle number. Mode is the one that appears the most. So looking at example 4, the mode of this would be red, because red has the highest frequency in this. All right, makes sense? All right, so look at the tables on the bottom of page 856. Because this is important. That first graph is symmetric, right? When the data is symmetric, the mean and the mode are the same value. the mean, median, and mode. All of these three are the same when the data is symmetric. You see that in the picture? Look what happens when it is skewed left. So there's very few small values, but everything is weighted to the higher values. What is going to happen? Well, the mode goes the farthest out. It's the one with the most. The middle is a little smaller, and the mean is even smaller. So when it's skewed left, it goes mean, median, mode. This order, mean, median, mode. That order just completely changes when the data is skewed right. It goes mode, median, mean. Does that make sense? Because that outlier, the outlier pulls the mean towards it. Like with that house price, it pulled it towards a higher value. All right, so that's important. So that's measures of center, all right? Now, let's talk about measures of spread. All right, so we did center, mean, median, and mode. And now we will do spread. All right, the first measure of spread is standard deviation. And standard deviation really works best in a symmetrical distribution. That's really when it actually works. And we did some of this in at the very end of Algebra 2. There was one lesson on this, all right? But what is the standard deviation? The standard deviation is really the average distance one of the numbers is from the center. It's really the average distance that one output, one number is from the very center. So the first thing you have to calculate when you calculate standard deviation is you have to calculate the mean. And then once you get the mean, so the best way to do this is just to I'm going to go back to that list that we had. Actually, let's go back to the list that we put in. 3, what did we say? 3, 8, 5, 6, 6. I'm going to change that last one. Let's go back to 10 in our list, okay? I'm going to put these in order now. 3, 5, 6, 6, 8, and 10. So here we said the mean was what, 6.3? I believe that's what we said it was, right? So the standard deviation, really the sigma is going to be the square root of, our denominator is how many there are, 2, 4, 6. So 6 is our denominator. All of this is under the radical, okay? And then it's how far each one of these is from the mean. So it's 3 minus 6.3 squared plus. You just take each one of these, right? 5 minus 6.3, that's squared. So that even though you have a negative number, when I square it, it becomes positive, all right? Plus 6 minus 6.3 squared plus 6 minus 6.3 squared, so forth. You get the idea? 8 minus 6.3 squared, 10 minus 6.3 squared. Or, if you go to your calculator, it has calculated it for you. And the standard deviation for this is 2.21. Do Do you see that in your calculators? Go to your calc. Stat, calc, down, down, down.
We had changed it to.
Change that 100 back to 10. And they used a different set of data. All right. So the mean was 6.3. The standard deviation is 2.2. Do y'all see that in your calculators?
Yes, ma'am.
So what does that mean? What does that mean? That means that the height of the curve, the mean, median, and mode are all the same, right? If this is symmetric, and it's at 6.3. And we're going to talk more about this later, but one standard deviation to the left is 2.2. What's 6.3 minus 2.2? 4.1, right? And then one standard deviation to the right, 2.2, that's 8.5. This is one standard deviation from the mean, such that it would be symmetric. And we're going to talk about percents and how the further out we go, there's fewer on both sides. All right, but it is a measure of spread. All right, that's the whole point of this one. All right. Now, they do the range. What is the range? The range is easy. The range is the high minus the low. That's all the range is. The high minus the low. All right, so here, looking at, all right, so that's range, right? The range for this data is 10 minus 3, which is 7, okay? The standard deviation, I think we use the same data, right? 2.2. That means as we move 2.2 from the center on both sides, the data is symmetric. It changes, okay? And we could move 2 standard deviations away, and it would be symmetric, and 2 more, right? 1 from each side. To do the box and whiskers plot, you have to have these 5 key values. The smallest number is your min. The highest number is your max. Okay, I've written them here. Good. This median is the median. So I walk my way in. It's right here, 6. So that this is my upper numbers, right? And this, lower numbers and upper numbers, right? How I calculate quartile 1, it's early, right? How I calculate quartile 1 is then I take the median of this quartile. So what's the median here? 5. That's quartile 1. Quartile 3 is the median of the top numbers. So if I were drawing my box and whiskers plot, so right at 6 would be, I'd do like an x-axis, right? 3, 8, 10. All right, so my box goes from quartile 1 to quartile 3. So 5 to 8. That's my box. Then the whiskers go to the min and the max. So what do? We find the median. then we're grouped into two different sections, the lower section and the top section. You take the median of the smaller section, that's your quartile 1. The median of the upper section is quartile 3. Okay, we can graph this. Okay, so let's try it. With this set of values we've all got in there, right? All right, so if you go to stat, nope, take that away. Second stat. Second stat, I take that away too. Ah! Okay. Oh, no. Okay, yeah, it is second. So it's second stat plot, which is the y equals. See, I gotta get this right in my brain. Second stat plot. And then you should have stat plots, right?
Wait. What is it called?
Second y equals. When we graphed equations, okay? So plot 1 should be off, right? Okay, hit enter, we're gonna turn it on. Okay, so highlight on. So on off is the first row. The second row shows us, well, how do we want to show it? And we're going to choose the box and whiskers. So you only go left and right? So it's for mine, it's the bottom middle. Do y'all see it? Bottom middle. I'm going to hit enter to choose that one. Okay? It already tells me my X list is list 1, right?
Mm-hmm.
And then my frequency. Okay. Now, the Lord willing, when we hit graph, it's going to happen. Hit graph. Our range is wrong. Wait, maybe our mode is wrong.
I just got like a bunch of curves.
You know why?
An error.
Go in and clear out y sub 1 and y sub 2. Go y equals, clear out y1 and y2. Yeah, I had equations in y1 and y2.
Okay, so then what do we do? Like restart.
Second line.
Okay, then you have to do your window. Wow. Okay, that's why my X-min is 6,500. We need to go from, I'm going to go from 0 to 12.
For X max.
Yeah.
And then Y same?
I don't think y even matters. Okay. I guess y does matter. Okay, yes. And then I see this. So my X-min, 0 to 12. I put my y window 0 to 12, but you could go 0 to 20. Would that move it? No, it doesn't matter. It's just going to be at the top.
I keep getting an error.
Wait, how did